Have you ever seen at the beach, or maybe in an aquarium, those clumps that look like antlers or like little trees? Golden yellow, hard, standing dead still on the bottom of the sea. Most people walk right past them thinking the same thing. Oh, that's a rock, or that must be some kind of underwater plant. Here's the first thing I want to tell you today. Both of those guesses are wrong. It isn't a rock, it isn't a plant, it's an animal. And not one animal either, millions of them. Hi, I'm Dr. Gray Parrot, and welcome to the Animal Truth Lab. Today's star has a name that tells you exactly what it looks like, the staghorn coral. Scientific name, Acropora cervicornis. Pull that word cervicornis apart, and you get cervus, deer, and cornu, horn. Put them together, and you get a stag's antler. Because those arms of its, forking and branching as they climb upward, look just like the antlers on the head of a stag. A little over 200 years ago, the scientist who named it for exactly that shape. Now, I've been busy with something lately, and it has everything to do with this creature. I've taken a job as a building inspector. I go around, one by one, checking on the greatest architects in the entire animal kingdom, seeing whether the houses they put up are actually up to code. Every one of these builders is more impressive than the last, but they all have one thing in common. Whenever I walk onto a site, I can always find whoever's in charge of the building. Sometimes it's a single, hard-working engineer. Sometimes it's a whole crew splitting up the labor. I ask one question, who built this, and I always get an answer. Until I came down to the seabed and stood in front of this, one of the single biggest work sites on the whole planet. I had my checklist out, ready to go down the line and find the person in charge. And after I'd been over every inch of the structure and asked in every last corner, the only answer I got was one word: nobody.
No chief engineer, no architect, no blueprint, not even a foreman anywhere in sight. And that is today's mystery. A structure this enormous, who on earth built it? Let's inspect it one item at a time. Inspection item 1. This structure, who is actually building it? Like I said, it isn't a rock and it isn't a plant. It's an animal. And how are scientists so sure? Because a plant makes its own food out of sunlight, but this antler can't do that. It has to catch its food. It has a mouth, it needs to eat. And anything that catches its food to eat, well, that's an animal, isn't it? And here's the part that's really amazing. What you think of as a clump of coral isn't one animal at all. It's an entire colony. A single clump of staghorn coral is home to thousands, sometimes millions of tiny animals, and scientists call them polyps. Each polyp looks like a shrunk-down sea anemone. A mouth in the middle, a ring of tentacles around that mouth, and tucked along those tentacles, tiny harpoons that can fire. These little harpoons have a name. They're called nematocysts. And the instant some passing critter brushes against one, it snaps out with a flick, stuns the prey, and hauls it back into the mouth. And inside that mouth is a stomach to digest the meal. So picture it. Each of these animals is tiny, and there are millions of them, all of them living flesh, joined one to the next into a single continuous sheet. And they even share their food with one another. They don't each live their own separate life. They are one single community. That rock you thought you were looking at is actually a living, feeding city of animals. Inspection item 1, I'll put a check in the box. This structure is built by millions of miniature animal workers. But which one of them is the foreman? Nobody. Let's keep going. Inspection item 2, where do the building materials come from?
And here I want to ask you something. Take a guess first. To build a house, you need bricks, you need materials, right? So these millions of workers building something this big and this stone hard, where are they getting their materials? Where are their bricks coming from? Are they hauling them in from somewhere down on the seabed? Got your guess ready? The answer is they don't bring in anything. Not one single brick is brought, not one is carried in, because they make their building material themselves, by hand, out of their own bodies. Every polyp has a special layer of cells at the base of its body, and that layer does something remarkable. It reaches out and grabs the calcium that's already dissolved in the seawater a little at a time, adds carbonate to it, and lets it slowly crystallize and harden into a kind of stone. That stone has a name, aragonite. It's really just limestone, the very same calcium carbonate family as a stick of chalk or the shell of an egg. In other words, every brick in this whole structure is grown by the workers right out of their own bodies. And the very first thing each polyp builds this way is a little room for itself, a small cup-shaped cup of limestone, and it moves straight in. The entire reef, when you get down to it, is just millions of these little rooms, stacked layer on layer, generation on generation. So it isn't a plant living inside a rock. It's an animal that built itself into a rock with its own two hands. Inspection item 2, passed. Materials made in-house, nothing hauled in at all. In that column, I'm stamping a great big pass. Inspection item 3, and this is the one I find hardest to believe, power. Building takes strength, it takes energy, right? Now, you might be thinking, well, it just catches little critters to eat day and night and builds on the energy from its food. Wrong. The energy it builds with, the vast majority of it, the coral doesn't catch that itself at all. So who's supplying the power? A group of tenants living inside its body.
These tenants are a kind of extremely tiny single-celled algae, and their name is zooxanthellae, the coral's symbiotic algae. And they live inside the polyp's cells, not beside them, inside them. How crowded is it in there? A piece of coral the size of your fingernail holds over 1 million of these little tenants. And they do something that only a plant can do, photosynthesis, turning sunlight into sugar. And most of that sugar they don't keep for themselves. They hand it over to the coral, like paying the rent. 90% of everything the coral lives on is grown by these tenants, out of sunlight and paid upward. So the power source for this whole structure, you might not believe me when I say it, is the sun. Sunlight pours down into the sea, it feeds the tenants make sugar. The sugar feeds the coral, and only then does the coral have the strength to stack that limestone up layer by layer. Sunlight turned into a city of stone. And scientists have found something wonderful. The very same coral builds far faster when the sun is out than it does in the dark. This has a name, light-enhanced calcification. It's basically a solar-powered construction crew. The sun comes up and the whole site runs at full throttle, the sky goes dark and the pace slows right down. And let me be clear about who does what. The one actually doing the building is always the coral itself. The tenants only supply the power, they don't lay a single brick. So when night falls, does it just stop working altogether? Not quite. At night, the polyps push out all their tentacles and use those little harpoons I told you about to grab the plankton drifting past in the water, a little something extra on the side. Sunbathing by day, catching midnight snacks by night. But the main power plant that keeps the whole site running is always that crew of solar tenants. Inspection item 3, pass. And I want to add a special note in the margin. This is the most economical worksite I have ever inspected. The electric bill, the sun picks it up. Inspection item 4. What exactly did it build, and does it build fast?
Now, when it comes to stone, we all carry the same picture in our heads. Stone grows painfully slowly, so slowly you couldn't feel it change in an entire lifetime. And plenty of people assume coral is the same way, adding just the tiniest bit each year. Wrong again. Staghorn coral is one of the fastest growing corals in the whole Caribbean. When it's healthy, its branches can stretch outward by 10 to 20 centimeters in a single year. 10 to 20 centimeters? What does that feel like? About the span of your open hand. One branch in 1 year grows the width of an open hand.
That is no slow-motion stone. That is an underwater forest, sprouting new limbs and shooting for the surface. It's got a little trick behind this. At the very tip of every branch sits one specially fast-working polyp, whose entire job is to charge forward and stretch the branch out longer. And the polyps around it take care of thickening it up, forking upward again and again, looking more and more like an antler. And that, of course, is where the name came from. And there's a reason it climbs so desperately, building tall and building dense. It's racing for sunlight, racing for space, trying to be the first one to stake out the ground. It is the pioneer architect of the seabed. And then the warmest thing happens. This great antler forest it's built, it can't possibly fill all of it itself, so it turns into the busiest neighborhood in the entire sea. In among those dense branches are countless nooks, countless little rooms, and little fish darting through them, playing hide and seek, finding safe places to have their young, ducking away from the big fish hunting them. Scientists say that in the whole western Atlantic, the home with the most kinds of life packed into it, the busiest address in the ocean, is exactly this kind of reef, the one that Staghorn coral builds. It didn't just build itself a home, it built an entire city and then handed out the keys to tens of thousands of tenants. Inspection item 4, built the most alive, most life-filled community in the whole ocean. A great big pass.
Inspection item 5, and this is the most outrageous line on my entire checklist. So outrageous that when I went to stamp it, even I paused for a second. A normal building, you break it, you snap a piece off, what do you call that? Damage, destruction, right? But Staghorn coral is not like that. Snap off one of its branches, say a hurricane sweeps through, or a big fish blunders into it, and that broken off branch, tumbling down, doesn't just disappear. It settles onto the seabed, grabs hold again, anchors itself back down, and then it grows into an entire brand new coral. You heard me right. Break it, and it doesn't get smaller, it gets bigger. On my inspection sheet, there's only one way I can write this down. Breaking it doesn't count as damage, it counts as an extension. The more it breaks, the more of it there is. And here's the thing, human beings have taken this exact trick and turned it around to save the coral. Scientists snip healthy coral into little pieces and hang them out in underwater coral nurseries. Picture a plant nursery but on the seabed. Grow them up and then plant them back one by one onto reefs that have been damaged. The whole scientific principle behind that rescue is that same ability. The more you break it, the more of it there is. Now, you might ask, apart from snapping off branches, doesn't it ever just have babies the normal way? It does, and the way it does it is one of the most spectacular sights in the entire ocean. Once a year, just once, usually one night in late summer, a few days after the full moon, across the same stretch of sea, tens of thousands of staghorn colonies, as if they had all agreed on it in advance, at almost exactly the same instant, released tens of thousands of tiny beads, each one bundled up with egg and sperm, all together, all at once, up toward the surface. The whole sea looks like an underwater fireworks show or like a snowfall drifting upward. The little beads rise to the surface, split open, mix, fertilize, and turn into brand new life.
Why does everyone do it all at once? Because a single coral colony usually can't fertilize itself. It needs the sperm and eggs of other colonies. So they have to pick the same night and release together so that everyone's beads meet up at just the right moment, right at the surface. The whole reef counts down together and lets go together, a performance with no conductor and yet not a second off. Inspection item 5, an architect that expands by being broken and throws reef-wide fireworks all in perfect sync. Pass. And you know what? I think I'll give this one an extra star. Okay, we've inspected this far and every stamp that needed stamping has been stamped. But that question I started with is still sitting there, unsolved. A structure this impressive, who on earth is directing it? Who exactly is the foreman? Let me tell you the answer I found. There is no such person. It's not that I couldn't find them, it's that there simply isn't one. The staghorn coral and every single polyp on it has no brain. You heard me right, no brain. All they have is a very simple spread-out nerve net that can feel and can react, but there's no central command post anywhere. So no brain, no blueprint, no foreman. How does a city this complex ever get built? The answer is the thing I find most beautiful in this whole episode. It's built by everyone just building their own. Each polyp does exactly one very simplest thing: build its own little room and take good care of it. It has no idea what the whole reef looks like, and it doesn't need to. Millions of them, each one minding nothing but its own tiny patch, and the result is a vast, intricate city that feeds countless lives, growing itself all on its own. Nobody is directing, and yet every last one of them is in exactly the right place. Science has a name for this. It's called self-organization. I have inspected a great many architects, and this is the very first time that in the box marked person in charge, the only thing I can write is all of them, and not one of them is the boss. And that doesn't cost it a single point, just the opposite. It's the most astonishing pass I have ever handed out.
Once the inspection was done, I couldn't help taking a step back just to feel how big this whole structure really is. A single clump of staghorn coral grows fast, but it's only one small piece of this city. A whole coral reef is countless clumps of coral, generation after generation of polyps, taking thousands of years, around 5,000 years, to slowly stack it all up. It is one of the largest things on the entire Earth, built by living creatures, by hand. So big that... wait, hold on. I nearly got that wrong, and I need to stop and say it properly. You may have heard people say that coral reefs are so big you can pick them out from space, from a satellite. That's true, but be careful with it. The thing you can recognize from space is a coral reef system, like Australia's Great Barrier Reef, something absolutely gigantic, the scale of many, many corals all put together, not the single clump of staghorn coral we've been talking about today. And another thing, staghorn coral lives over on the Caribbean side of the world. It's a completely different place and a completely different coral from the Great Barrier Reef on the far side of the planet. Don't go mixing the two of them up. Okay, got that straight. Here's the point. These motionless little animals with no brains at all took thousands of years and turned the seabed into one of the most alive places on the whole planet. And here's a lovely little detail. Coral's skeleton is like the rings of a tree. Ring after ring, it records the temperature of the seawater around it. This whole city of limestone is itself a book written in the history of the ocean. But every single time I reach this point, my inspection file has to turn to its very last page, and its hardest. This, the greatest architect the ocean has ever known, is now one of the most fragile living things in the sea, and it has run into two enormous troubles. The first one is called bleaching. When the seawater gets too hot, and every year it overheats more easily than the last, the coral can't take it, and it throws out all of those solar tenants living inside its body. The tenants leave, and two things happen in the same instant. One, the coral's color vanishes and it turns a ghostly pale white. And two, its main power plant goes offline and it begins to starve. And let me be really clear about this because it matters. Bleaching is not the coral being dyed white by some bleach. It's the coral itself pushing out the tenants inside it, exposing the bare white skeleton underneath. If the seawater cools back down quickly, the tenants have a chance to move back in, and the coral can still be saved. But if it stays too hot for too long, and it happens too often, the coral can't hold on. The second trouble is a disease, and it's called white band disease. Starting in the late 1970s, the Caribbean was hit by an outbreak of a disease that attacks staghorn coral specifically.
It starts at the base of a branch and works its way up, killing the living tissue and stripping it off, section by section, leaving nothing behind but a length of bare white bone. Add hurricanes on top of that and the seawater turning acidic, because when seawater turns acidic, the very stone the coral needs to build with becomes harder to crystallize, harder to lay down. Put all of these together and the result is heartbreaking. In just 30 years, staghorn coral across the Caribbean fell by more than 80%. In some places, it dropped to less than 3% of what it used to be. What once carpeted the seabed like a forest of antlers is now, in a lot of places, nothing but silent white bones. And so it has been officially listed as critically endangered, which means it is a single step away from being gone. But I don't want to leave my inspection file sitting on a note that sad, because this architect has one ability that no one else has. Remember it? The more it breaks, the more of it there is.
And it's precisely that trick that has turned into humanity's single greatest hope. Right now, scientists and divers all over the world are all doing the same thing, cutting healthy staghorn coral into little pieces, growing them up, and planting them back into the sea. On the night the coral sets off its fireworks, they row out to catch the tiny beads floating up and bring them back to the lab to pair them off and raise them into baby corals. And they go out of their way to pick the corals that handle heat better, the ones that aren't so afraid of high temperatures, and they keep those and pass them on. Human beings are learning to be its foreman. You see what's happened here? That structure, the one where at the very beginning, no matter how hard I looked, I could not find a single soul in charge. Now it's us. We're the ones doing everything we possibly can, trying to be the one who helps it. So in the end, here's how I want to sum up this whole inspection file. This, the largest structure on the seabed, has no architect, no blueprint, no foreman, only millions of brainless little animals, each one diligent in its own way, who used their own bodies and relied on the sunlight to build a whole living city and to feed more lives than anyone could ever count. It is the ocean's greatest architect, and it is also its most fragile one. And that ability of its, the more it breaks, the more there is, happens to remind us of exactly one thing. The most fragile architect of all might just be the most resilient one, too. I'm Dr. Gray Parrot, and this is the Animal Truth Lab. Next time, we'll go and inspect another masterpiece of life together, one you have never once thought about. See you then.
Next time, the Animal Truth Lab investigates a case about falling in love, and the star is a tiny artist. A male bird builds a beautiful house by hand, but nobody lives inside. No eggs, no babies. It's not a home, it's a stage to win the girl he loves. He's mad about blue, and when his neighbor looks away, he sneaks over and steals those blue treasures. What on earth is this little artist? Want the answer? Hit like, subscribe so you don't miss it, and share it with your best friend. I'm Dr. Gray Parrot. Thanks for coming to the Animal Truth Lab. See you next time. Bye-bye.